My name is Tom Schindel. I'm CTO and co-founder of a small company located in Austria, Central Europe. I'm an Eclipse committer at various Eclipse projects, starting from E4 to Platform UI, going over to EMF, and I'm the main developer of the tool I'm going to present at Runtime I'm going to present today. My Twitter handle is ThompsonTom. So, some words about FX Clipse, the project I'm working on. It's an open source project led by Best Solution. All sources we are developing are provided under EPL, so you can use them for free. You can even modify them, but if you modify our sources, we expect that you give back what you modified. But you can use it for free. We started the project, or I started the project in summer 2011, and it's now 1 year old, a little bit more than 1 year, and I think I'll show you really interesting and cool stuff that we accomplished in this time. We release quite often, so I try to release every 6 to 8 weeks, and each release gets downloaded by around 2,500 times per release. So it's the best open source stuff I ever released, so that many people are downloading it every 6 weeks. We have community support at our homepage, and you get commercial support for the stuff I'm presenting from our company. What you should take away from this talk, that's all the most important things, is JavaFX 2 is really a great technology to create really good looking UIs. You can really create really astonishing looking, fresh looking UIs using this technology. What you also should get with you is that it's not only NetBeans that provides tooling for JavaFX development, it's also at Eclipse that we provide stuff for you. So if you are an Eclipse user, you're not forced to switch over to NetBeans to write JavaFX applications. And one more thing you should take away from this talk is that not everything that comes from Eclipse is bound to SWT. So many people think that everything that comes from Eclipse, they have to use SWT to make it work, but that's not true. Most technologies developed at Eclipse don't use SWT at all. They don't care about SWT. So the Eclipse, the project is split in 2 parts. The first part is about the tooling, so that we provide you tools for developing JavaFX application, but we don't stop at the tooling level. We also provide you stuff for the runtime. So when you have JavaFX applications, we provide you support for OSGI and all the stuff. So we don't stop at the tooling, but also go into the runtime so that when you run the application, we provide components you can use for free so that your applications are better structured, more maintainable, and all the stuff is provided by this project. So when we talk about JavaFX applications, well, what they are built of are, in fact, they're using Java. So you use plain Java to write JavaFX applications. You don't have to learn any new language like it was in the old days with JavaFX 1. So what we can provide as a tooling provider is we can provide you a class path container that finds the JavaFX libraries on your system. The problem until now is still that JavaFX is not part of the bootstrap class path. So you have to add it as an extra char to your class path when you boot up your applications. And that's true even for IDEs. They have to find out where your JavaFX char is located. Since I think Java 7 U6, update 6, they ship JavaFX as part of Java 7. But they ship it, but they don't put it on the boot class path. So you have to add it your own or have tooling that does it for you. So we're providing a class path container for Eclipse so that Eclipse finds out your JavaFX char on the system and adds it to the class path so they can write easily JavaFX applications. Naturally, we provide wizards like project wizards that help you to get a project started, to get everything set up for you without having to do everything manually. The next thing that you use when you write JavaFX applications, you have to use CSS, I think. So it's fairly impossible to write a JavaFX application without using CSS. The problem is that CSS is normally written for IDEs, they are for web development. So JavaFX has all its own properties, it has its own meanings and stuff. So you need a specialized editor for CSS to really make use of JavaFX stuff. So it's really important that you have a good CSS editor whenever you write JavaFX applications. So that's why we started writing a custom editor, not reusing the one you get for web development, but we bootstrapped a completely new one using a texture framework called Xtext, where you can create your own DSL. And the CSS is nothing more than a DSL to explain how things should look like. It's a DSL, it's a domain-specific language for styling, right? So nothing more. And the last thing, you are not forced to, but it's encouraged that you use FXML to create your UIs. You get the scene builder tool to do it visually, but I'm not a guy that likes to click around and drag things around. I'm better at typing stuff. I'm a developer, I'm not a designer or something like that. So we developed a specialized XML editor that really helps you to write FXML files by hand. And FXML itself is nothing more than a serialization of an object graph. So you type it and then you deserialize it at runtime and get up your node, your scene graph out of the FXML file. And the last thing that JavaFX comes with is a specialized ARM task that you can package up your applications to a native Windows MSI installer exe, a DMG file for Mac, RPM packages. So we provide you an extra editor that helps you to configure the tooling. Yeah?
Questions at the end?
No, you can always ask questions.
Oh, okay. I'll let you know if this is CSS extended or the same as we know in HTML.
Well, CSS itself has a meaning of selectors. So selectors, I think they're not supporting everything that you get from CSS3 selectors. That's a subset of it, but it has its own properties. So, for example, they have -FX background color. They have special things that you can set a padding or an H gap on an H box, for example. So those properties are not part of the CSL spec. In fact, they are part of the HTML spec. HTML says you can put a padding on a node or on a span or on a div. It's not the CSS spec that tells you that. And that's what our editor does. It provides you specialized typing. But I will present the tooling and you'll probably see it, right? So I wanted to talk about, well, JavaFX lets you package up your application as an MSI installer DMG package. So it has extra on task, and we have an editor to help you to define the information the on task needs for input to generate your application that you can install. So now it's the first time I'm going to present the basic tooling function that I just described that helps you bootstrap an application, create and edit an FXML file, connect to a controller whenever you have to execute code. You have the FXML file, but it's a decorative format. When you want to run code, you must connect it to a Java class or a scripting class. I show you how to edit a CSS style sheet and how to export the application. So we have a specialized project wizard that allows you to create a project. That's sample fx2.
What version of Eclipse are you using?
I'm using Eclipse 4, but we support upwards Eclipse 3.7 and 3.8. So this is Eclipse 4.2.1 in this manner. But we support all flavors of Eclipse, and we're not going to raise the level, so we will stay at least another year on. The lowest level is 3.7. So that's what you're going to support. So I've now created a project for me. I create a package. Sample. And here I have another wizard that allows me to create a JavaFX main class, my sample. So when you look at the JavaFX main class, it simply extends a base class from JavaFX. It's called application. And then you have the main method and call launch. And then this is where your main application starts. So you create a border pane. Is that big enough for you in the back? So do you see the code? Or should I make it bigger? Yeah?
Where do you get this
You can download it from our homepage. That's, I had it on the first slide, I think. So it's, you get it from here. We provide you a complete download of Eclipse compact with JavaFX, or you can use an update site to install it in your host Eclipse. So the easiest path is downloading a complete Eclipse bundled with the JavaFX tooling. So that's the easiest. You can download it, get started in a minute. So the wizard created a class that extends the application class, and now create a border pane. And that's normal Eclipse Java tooling, so nothing special in here. We set center, new button, hello, J1. Then we need to create a scene. We pass in the border pane, we pass the scene. Oh, sorry, okay. Set scene. Then we give it a size, set width 200, and primary stage set height 200, and primary stage show. That's all we need to do to have a basic JavaFX application. Then we can simply launch the application. Should get up this example application. It's a similar Hello World example for JavaFX applications. So I said, well, we now have our example with only using Java, but the best thing would be if we use if we export the application with it, then we have a specialized editor. It's not redrawing. So this editor is used to help you to configure the on task I talked about. Whenever you export the application, you want to have an installable application. So this editor allows me to insert my company's name, the application version I'm using. It asks me for the main class the application starts with. And then I have down here, I can say I want to package it for native packaging. So then when I export the application, it creates a build XML file on the left hand here. And now kicks off in case of Mac, it creates a DMG package which is used in Mac to install the application. In this case, it also packages in the complete GDK. So the users don't have to have Java installed on the system. Everything comes in with this DMG package. So even I think in future it would be even possible to put it on the App Store like this. So that's what I think Oracle is working at. So now the packaging is done, and on the left-hand side we have in the deploy folder, we have bundles, we have the DMG package, and that would be default Java Mac installation of applications. So it should open the GMD somewhere. It is not. Here it is. Here it is, the GMV file. So I'd simply move it to my applications folder, and then I can launch the application like I would always. So.
Do you have to do anything special if you're working in a Maven project?
Oh, we are currently not supporting Maven. The problem with Maven is that, well, you have to tell Maven first where it has to find the JavaFX jar as well when it compiles things. So we didn't look at Maven at the moment. So I can't give you an answer for that. Okay, so this was the easiest application lifecycle. The next thing I'd like to show is our tooling support for FXML editing. So we create an FXML file. We can leave it as a border pane. It's sample. And an FXML file is simply this FXML description. It's a border pane, and when we now want to do the same thing we did in Java, we need to have a center. the nice thing is we have integration into the Java world. So when we have here a center, we know in Java we have to call a setter method, and we simply infer that we can show the Java doc of the setter method. So you get all the information you get in the Java tooling as well, but editing the XML file. So with a center, and in here we can create our button, and then we can have a text attribute, hello J1. The nice thing about editing the FXML file is that it's declarative. So what we have in here is I can show you a preview while you're editing the file. So we have a tab down there which shows live what you're doing on the upper hand. So when I change something here or add some things, then you immediately see what you're doing. So you get what you see is got the get feeling while editing the FXML file. So as I said, I think I'm a lot faster doing the editing by hand than dragging things around, but that's my personal opinion. So now we have the FXML file. Now we need to theme it, and for this we need our CSS. So we create a CSS file, new other. Sample CSS. And if we now have our button, we want to connect our CSS file and the preview to the CSS file. So what we insert here is a simple information that says sample CSS. And now the nice thing is when I go down here and, for example, redeclare the button to, for example, having a FX padding with 10, it really gets applied to, let's make it 20 that you see it really. So while you're adding the CSS file, reapplying the CSS on the live preview, and you see what you're doing with CSS on the fly. As you saw, you get auto-completion support, so those are all the special attributes that you can send on JavaFX nodes. So we provide you information about them, and the last feature in the last release we added was when you hover this, you see the declaration, what is behind the scenes. So at FX padding, you can put one value as a size, or you can put 4 values, the left, top, bottom. We show you the information about it. We even allow you to drill down if you want to know what is a size. Then click on the size. A size tells you, okay, it's a length or percentage. And if you click on a length or percentage, then you see a length is made of a double value, and afterwards you have pixel or millimeters or centimeters or points in the end. So all those informations are provided by the tooling for you. We even use this information that we have collected in here to provide the wizard that helps you to specify. It really knows what you want to do. So it really helps you, the auto-completion, even values, not only the attributes. Right? So in this release, we simply do the auto-completion stuff. But in the next release, we're going to use this information to validate your CSS on the fly. The really nice thing about the CSS and everything in JavaFX is that, well, you can create your own control with your own property set. So we have to have a story that that allows you to teach the tooling what properties you provide to us. So that's why we created a small new language which allows us to define what's going on the behind the scenes. And when we look here we find the padding. The padding is defined here, so that's our language that tells, okay, we are in a region, it's up here, all the specifications, we are a region expands in JavaFX apparent, and that's why we know what properties are available. So we have a structured format to store information, and if you create your own control, you could create your own CSSX file, provide it to us, and we can add it to our auto-completion story. So in future, we will search the class path for those files. If they are there, we help the tooling to help you. Okay, that's the main story about the main stuff. Then you use JavaFX for JavaFX development. So where did we left off? Here we left off. So the next thing is some advanced tooling that we provide. It's not only the basic stuff, but the first thing, well, I was not happy at the beginning with FXML and XML. XML is a very noisy format. So I created a small language that I called FXGraph that has a JavaScript object notation-like syntax. So it feels much more natural to create an object graph using JavaScript object notation. And this language compiles to FXML in the end. It doesn't compile the bytecode, but it creates FXML at the back end. Then we have some tooling for OSGI, so that you have OSGI applications, or Bootstrap OSGI applications, and they provide you an SVG converter that allows you to take an SVG, convert it to FXML. The converter is written in Java, pure Java in the end, right? So you can use it even on your web server to create FXML files of SVG. So I'd like to present you in a short demo the tooling the FXGraph tooling. So instead of creating a FXML file, I create an FXGraph file. This time I use a grid pane, that's fine. So as you see here, the syntax is, well, similar to JavaScript object notation. It also provides you all the autocompletion stuff. So I can go here and say, I want to have a button, and the button has a text, hello, J1. So that's the same thing. You see, and on the left-hand side, I create the FXGraph file, and by that, also the sample FXML file got created. Whenever I hit save, I generate the FXML file out of the FXGraph information. The nice thing in here, you have autocompletion for all and everything. So I say styled with, then it's styled with our sample CSS. So we apply the sample CSS. And then we can say controlled by, and then we can give it a Java class. They can set the controller on. So now if I control a Java class, whenever I hit the button, I want to run a method on the Java class. So here in JavaFX, you say on action, controller method, and then it looks at this controller class and finds out, oh, there is a method hello world, it's annotated with FXML, and it presents it to you that you can say, okay, that's it. I now connected my FXML file to the Java controller. When I run the class and hit the button, then the Java controller method in here is executed. That's the method in here. We not even do that if you have a problem in here. We show you that there's a warning, and we provide you with quick fixes. Okay, it finds out there is no hello world method in there. Would you like to create one in your controller? If I hit this one, then my controller magically gets a new method, hello world 1. So all the things that you expect from tooling in Java and you're used to in your Java world are here for FXML. Even it's not only a thing that is part of FXGraph, even in the FXML world we can do the same. So you get the same autocompletion syntax and values in whether you use FXGraph or something different. A nice little feature of FXGraph is that, well, normally when you do designing, then it helps you to see the grid lines for a grid, right? So you don't see it really, but it's around here. There's a line drawn. The problem is that it's good at design time, but at runtime you don't want to see the grid lines. So what we have in JavaFX, in FXGraph, is we can prefix such an attribute with preview. Then the preview shows the grid lines, but the resulting FXML file doesn't hold those attributes. So you can really make up your UI, because things change. If you have a drop-down box with a long value in it, it gets bigger. So it might destroy your design. And so you can try things out using the preview keyword, because in the resulting FXML file, it's not there. It's only there for the preview in your IDE, right? So that's a quite little nice feature that we have. Okay, now that's for a little bit more advanced tooling. Let's go back to the slides. And now switch over to the basic runtime stuff that we provide. Well, I'm coming from Eclipse. Eclipse is based in OSGI. JavaFX itself has problems with OSGI. But the first thing that we provide is, well, for ordinary Java developers, we have some layout panels that if you are familiar with SWT layouts, then we have a grid layout, we have a row layout, which are not part of JavaFX. We have some dialogues, which mimics the idea of the SWT and JFace dialogues. We have FXML and Juice integration, and as I just said, well, the most important thing for us at Eclipse is that we use OSGI, so whenever you use something in Eclipse or want to use it in Eclipse, you have to use it by using OSGI. So the problem here is that JavaFX is not on the boot class path. It's not even spec'd. So OSGI has no idea where it has to find it. So the idea that I had, or what the way I followed was, there's something called Equinox extensions where you can add class loader hooks to find, well, you are asked if a class is searched, and I will then locate on the system the JavaFX jar for you. So this helps integrating JavaFX into the OSGI world. Hopefully this will go away in about 1 or 2 releases or updates, because then JavaFX is going to be on the boot class path, even on Java 7. On Java 8, it's for sure. I think it's already now, or it's going to be, but on Java 7, it's still not on the boot class path, but we'll get there, and then we can get away without the extension that we are providing. Let me show you how you can create a JavaFX OSGI application. Naturally, once more, we have a wizard. So you can create, it's called a plugin project. Sample OSGI 2. Then we select we want to create a JavaFX application. We don't want to switch. And now we have something similar that we had before, but now we are in OSGI. So we don't extend anymore the basic application class from OSGI, but we extend the base class that's coming from the FXClipse runtime project. In the end, you get some more information. You get the so-called iApplication context in Eclipse. That's what you get when you start an OSGI application in Eclipse. So it holds all the parameters you passed in as command line parameters and all this stuff. But it's quite similar. You see the code is then afterwards is completely the same than it is for ordinary Java applications. But we can now run it as an OSGI application. So really running on OSGI. It's not anymore plain Java application, but it's really bootstraps the OSGI environment and then brings up your complete application. So you get all the modularity stuff from OSGI you're used to already, together with JavaFX as a cool UI technology. What you can do with this, I can show you in a small demo, because I've written a small IDE using JavaFX, GDT core, the compiler that comes with Eclipse, and the web integration of JavaFX. So I have already here a project. I can create here a new class. I have now the completion or something like that, yeah, but in the end I have a small editor with syntax highlighting on the right. Public void main, static void main, static void main, string args. Out, println, hello J1. And then the nice thing is that in the background, while I'm typing, it's like in Eclipse, we auto-build in the end, on the back end, the class file and can run the class file from within here. So the really cool thing is that writing this took me 1.5 days. So I really have a small idea. No, it has no auto-completion and all this stuff, but it took me 1.5 days using OSGI. Technologies from Eclipse which are not bound to SWT like GDT core. Adding auto-completion would be probably 1 more day, and then things are gone. Things are working. So that's really, I think, a nice showcase what you can do at the moment you get OSGI, your JavaFX and OSGI working together. And that's really a cool thing, I think. Okay, that's it for the OSGI stuff. So naturally, well, we have the basic stuff, but we have also advanced stuff. So advanced stuff is, for example, if you create a view for Eclipse, where you have to present something like a chart, then it makes sense to use JavaFX. So we provide you components that help you integrate JavaFX into a view of Eclipse. Even we have things to bootstrap stuff. Then a very special thing in JavaFX is FXML, and FXML and the loading of OSGI, they don't really work together. I will show you in a minute why that's. So we help you or provide support that you can easily deal with FXML inside an OSGI container. And we provide you a very special thing. It's called E4 renderers, the Eclipse 4 framework, which this Eclipse is built upon, doesn't really depend on SWT. So you can rip out SWT and replace it with JavaFX. And you have a modern RCP platform which uses not SWT or Swing, but pure JavaFX. But you get a really cool platform. And we have support for Jammy unit testing, so you can bootstrap a Jammy unit test from it so that you can auto-test your applications on your continuous integration servers. So the problem with FXML and OSGI is that in OSGI you have always this visibility thing. So if you don't depend on something, you can't see it. The problem is that we have our application, we have our controller in there, probably we have our custom control, and we have our FXML file. On the other hand, we have a bundle, the FX bundle, which holds the FXML loader class. And as I said, FXML is nothing than a serialization of an object graph. So when the FXML loader loads the FXML file, it tries to create instances of classes. The problem is that the visibility rules in OSGI tell you my app bundle can see the FX bundle, but the FX bundle can't see my app bundle. So it can't load classes from there. So that's the real problem you're having when you use FXML plus OSGI. So you have to take extra care that you set a certain class loader, the class loader of the origin bundle, so that the lookup of classes is really working as you expect them to work in an OSGI world. So that's where we help you with some small features. So where is my sample DI? So we here once more have, well, in this case we have a plain application class. There is no subclassing going on, because what's happening behind the scenes is that we're using a dependency injection engine that looks up everything for you. And the cool thing about the dependency injection engine, it knows a lot about the scope you're in, so it can provide you special things. I can now simply go in here and say add inject and so-called FXML loader. For those who ever use dependency injection, that's the way it is. Then we have a factory injected when the class gets created. This factory has all the information. It knows in which bundle it is in, it knows the class loader, and it helps you by simply now creating or loading the class using factory. Then we can say we load the class relative to ourselves, to our application class, or we load it relative to the bundle, which is the root class path of your OSGI bundle. In this case, it's relative to us. I think I named the class, the FXML file sample FXML, and then the only thing is I have to call load afterwards. Wrap it, or cast it, and then wrap it and surround with try catch. What's return So this injection stuff helps you really, so you don't have to set the class loader. You can load things relative to your own class, and it's really, well, normally you have to write 10 lines of code instead of this one to get things working in OSGI, and this simple injection stuff helps you simply writing this and loading the stuff you use to it using the helpers we provide to you. So it really gives you very small code instead of writing 10 lines of boilerplate code when you're running in OSGI with FXML. So I already talked short about the Eclipse 4 stuff. So the Eclipse 4 framework, that's the core of it. Eclipse 4 is, well, it has the GRE, there's an OSGI, it has the Eclipse 4 application platform, which is condensed of a dependency injection container, a service model, a workbench model. But the really important thing that SWT on the outer side, it's really not part of the core framework. So when you use only the blue parts, you don't depend on SWT, but you get a really modern application framework to write your application. And what I did, I simply replaced SWT through JavaFX. So instead of rendering all your UI, like Eclipse does it with SWT, I simply render the UI using JavaFX. I can show you short how such an application looks like. Here it is. So we can launch it. Sample E4. This is a small application, so you can double click, you can minimize and maximize your stuff. Well, you get things for free naturally. You can, for example, pin a part to the bottom. So moving things around, you can detach them in a new window. So now the view got detached. All the stuff you get for free from the framework. So all the windowing, the plugging, and all the stuff, they are provided by Eclipse 4 to you. The only thing we do, we simply provide you the renderer that you can use instead of SWT. So that's really, well, the nice thing is you can really watch videos in here and scale them. And, well, that's all things that you get from JavaFX. It's nothing that I had to program. So that's for free. But the cool thing is, yeah, you can use a modern framework with dependency injection, a service model, and all the stuff for free with your JavaFX applications. So, although this thing is very young, we have already 2 commercial products that are built upon it. So one is from Thesis Duniver. They're providing simulation software for Audi, BMW, Ford, Magna, Volkswagen, and others. They have a client-server application built on top of FX Clipse and E4 on JavaFX. They're using state-of-the-art technologies like E4 and JavaFX, and they make heavy use of styling. The application then looks like this, what they're providing to their customers. So I haven't seen it myself. I only have the screenshots from them, but yeah, I think it's quite a cool application. And the second thing that is written on top of E4 and JavaFX is a system to observe what's going on in your factory. So when the product is going from machine to machine, you can really monitor what's going on. That's a very young company in Germany that provides that. So this is the application. This is the E4 application, JavaFX E4 application. So really looking very, very good instead of when you have SWT, it would take you months. And we've written the initial prototype that shows those applications in 2 days, simply because of using JavaFX, E4, and all the stuff it provides to us. A very nice thing what they're using, because you can monitor your fab, and it's a live monitoring from the server where they get the data from the machines and show where a product is in the cycle of your fab. And what they're using SVG. They send SVG to the server. They use our converter to convert that to FXML and then send back the FXML to the application and then animate stuff in the FXML at runtime. So it's quite a cool use of it. Okay, and the last thing I'd like to present is a project I've started working on, I think, two weeks ago. I call it FX for free. Effects for free. So you get effects for free. So it's really a small thing that, well, you have a JVM, you have OSGI, and you have the FX3 desktop above it, and then you have so-called apps in there. You have a browser app, you have a media app, you have your calculator app, and they're separate from each other using OSGI technologies. So you can create departments inside the OSGI application, and we're using this technology to really separate your applications. And when you run such an application, it looks like this. So you can launch, for example, the browser. Go in here, say go, and then you load a web page. So it's one of the simplest applications in this framework. What's really nice is integration. If you write an application, let's say we write an application for Java 1. So we have, where is my... So an application is, here's the application. So we want to have an application that says hello to Java 1. Hello, Java 1. We save this one, and then all we need to do to install the application is we drag it down here. Now we have the application in our running application. We click it, it opens and says hello, Java 1. So this is all done using plain OSGI technologies. OSGI is a really dynamic system, so it allows you to install and uninstall stuff at runtime. And that's what we are simply using here. Dragging over some file, it locates the file in the system and installs it into the OSGI environment, and then you can boot up your applications. Well, now imagine you would do this. You use Linux, then you use a standard desktop manager. You bring up the JVM, you bring up OSGI, and you bring up the FX3 desktop in full screen modus, and you have a kiosk system where you can install small applications. So it's probably in the future something that we are going to proceed and try to write such a system or provide it to our customers, because it could be in a very in an environment which is very controlled, where you don't have applications and the security constraints, that you can really use such a thing for your company to have it on your tablets or something like that in the end, right? So that's something you can do with the technologies we already have now. There you can use them, and writing such a thing is not more than a week of work. So, okay, that's it from, well, there some credits I have to have. Well, the icons are and the companies that provided the resources to me. And here once more you get the homepage, our company's homepage, and my Twitter handle. And yeah, any questions? Yeah.
The FX graph language.
Yeah.
Does anyone use that besides this tool?
I don't think so, no. Well, what we are we are currently working on a cross conversion, so you can convert your FXML, the FX graph, and then the FX graph back to FXML. So you have the full cycle. So you can always decide on, well, you always generate the FXML. So if you switch the tool, you switch to Scene Builder or you switch to NetBeans, you still have the FXML file with you. FX graph is simply a small little language that we invented for us, yeah. It's special to Eclipse project, yeah. Any other questions? Yep.
You use the custom language for supporting for example, right? Did you evaluate to use reflection?
No, it's more reflection. Well, we are using reflection, of course. Well, what the tooling does in the backend is it loads the FXML classes, or it's not a reflection, we're using GDT core, because GDT has all information about all classes in your class path, and you can ask GDT, tell me which methods are there. So it's not hard-coded in there, so we're using reflection on the GDT core level to find out what classes are there, what methods do they have, and if they match each other. So we're using reflection in this way. The reflection is even used not only by the FX graph tooling, but I didn't show it, but in the end, when we have an FXML file, where's one with a so the same what I showed with the FX graph language is possible with FXML itself. So when I go here and hit control space, it shows me, oh, there are the controller methods, right? So it even allows me, I say there's a controller method that's unknown. It provides me the same quick fixes. Do you want to add a controller method? So we're using in the backend, the memory model we're using is the same for FX graph and FXML. It's simply the representation in the UI that is different. I can show you the code where we go through and find out what classes are there. It's not Java reflection, but GDT core reflection. Okay. Any more questions? Thanks.